Welcome to the BioAT World's Trends from the Trenches podcast, your insider's look at the science, technology, and executive trends driving the life sciences. I'm Allison Prophet, editor of BioAT World. This episode is hosted by Stan Gloss, founder of BioTeam, a life sciences IT consulting company at the intersection of science, data, and technology. Today, Stan is joined by Fernanda Foertter, director at Voltron Data. Fernanda comes to give a candid assessment of AI in the life sciences and to update her 2021 remarks at the BioIT World Conference and Expo. Let's listen in.
Good morning, Fernanda. It's so nice to be talking to you again. It's been a while since we saw each other at BioIT World in 2021.
Good morning, Stan. It's nice to be here.
I'm so happy that we can have this conversation about AI and machine learning today. I'm not sure a lot of our listeners might not know who you are. Maybe there's 2 or 3 people in the world that don't. So for those 2 or 3 people, Fernanda, maybe you could introduce yourself, tell us a little bit about your background, and maybe tell us a little bit about what you're doing these days.
Sure. My background is kind of all over the place. It kind of partly fits my personality and my interests. So I started out as a physicist, a regular old computational scientist. And out of grad school, I ended up working for an agricultural genomics company. We were doing genetically assisted breeding of livestock. And that's where I got my first taste of bioinformatics, biology, and the plight of genomics. I spent 3 years there, and I ended up getting an opportunity to go work at Oak Ridge National Lab, building the world's top, fastest supercomputer at the time. And that was named Titan. And I was also part of the next supercomputer that was also #1, Summit. And I was also part of the next supercomputer, although I left a little bit before its install, which is now online and now #1 in the world, called Frontier. And so I had the experience of growing at scale. My work there involved training scientists to use this new hardware. At least it wasn't new to the world, but it was new to the world of science and computation, called the GPU, a graphics processor, which building the libraries for high performance computing, building the libraries for computational sciences, ended up creating the boom that is AI today. So the same math that that runs underneath AI frameworks were built because we were using linear algebra, because we were building those math libraries with NVIDIA to run scientific computations and simulations. So I spent 6 years there, and in the last 2 years where I was at Oak Ridge, I spent with the biological sciences. I came back to biology, and I worked at a biological sciences group, and we were doing some AI on health data, working with cancer data. And then after that, I ended up going to NVIDIA. I ended up going to work for the dark side, as we called it in government, and spent 2 years at NVIDIA as part of their healthcare team. It was a newly formed healthcare vertical. And I really enjoyed being there. But when COVID hit, there was an opportunity for me to join you folks at BioTeam and actually do something really important for COVID and help pharmaceutical companies do the work that they needed to do to solve this grand challenge that we had at the time in 2020. And so I left NVIDIA and went to work with BioTeam. And that was a really wonderful time there. And then I got this opportunity that I wasn't looking for. I was really happy at BioTeam, and I still apologize to this day for leaving so soon. But
we forgive you. That's okay.
But I got this opportunity to go work at a hardware company from some friends that were at NVIDIA that dropped my name. And it was my first chance to be a team lead, a director, and it was a great opportunity for my career. And you folks were gracious enough to say, go, get out of here, go do that. And at the time, we also kind of realized that AI was a difficult thing for pharma to actually take advantage of. The data sets weren't in a way that they were able to compute on them. And so we realized at the time that the readiness wasn't quite there. And so you'll see after leaving the hardware company that I was at, I ended up going to another startup. I really enjoyed the startup life. I spent a year there at that startup. And I wanted to tackle this foundational problem. That is the mashing of data, getting data ready to be computed on, and data that isn't regular, that is difficult. Scientific data is easy, right? You usually gather it from an instrument and it comes out of an instrument, or at least in the physical sciences, not so much in the biological sciences, but in the physical sciences, you get it out of through simulation. But in the biological sciences, you've got a lot of different instruments. You've got a lot of different temporal time, places where you've taken the data. You've got a lot of missing data. You've got a lot of different databases that you want to put together. And it's biological data or bio-related data is just very messy. But there's so much of it, and people want to take advantage of it. And that's really hard. And so I thought, I really like the startup life. Let me go do that. And that's where I'm at now. So I'm at a company called Voltron Data, Inc. I can't talk about exactly what we're doing because we're not completely out of stealth, but I can talk about the open source side that we are supporting, and hopefully I'll shed some light into it today.
That would be great. So maybe we could start off by understanding your view of the world in terms of the state of art, of where we are with AI today.
The funny thing is that because I went to hardware, the year that I spent away at hardware was enough that I've lost track of it, to be honest. The state of AI is changing so fast, and every day something new comes out. But, when I gave that talk at BioIT, the juxtaposition that we had where you have AI, figuring out what songs you like, or figuring out what you might buy next on Amazon, or maybe what you want to watch on Netflix, that is a very good, solid, AI problem, because you have very easy, regular data. You've got people that are basically offering their data by watching, shows or buying things, right? So you have the ability to control how you collect the data and where you collect the data to, which makes AI much easier to then develop. In the situations where you don't have control of how the data is being collected, you don't have control of where it came from, how sanitized it is, maybe not even labeled. Those situations, that world of AI is far less developed than the world of, social media, et cetera. And so the state of the state of the art in AI right now is that it's fantastic for serving you an ad. And it doesn't have to be right? It doesn't have to be perfect. And we see this all the time. You get an ad and you're like, I'm in my 40s. I don't need hair loss products. I don't know why you're telling me this, but then at the same time, if you want to do this for something that matters, like biology, like trying to figure out cancer, the state of the art is very precarious. It can do a very good job on a very narrow set of problems, but it's very difficult for us to extrapolate from the training sets and the training data because, number one, they're not enough. Number two, it's very easy to overtrain a model. And number three, it comes from so many instruments. You've got all sorts. Every time you go, just imagine, every time you go to the doctor, do you know what thermometer they're using, what brand? Do you know what, X-ray machine that they're using? There are many brands, there are many years, there are many types, right? Mm-hmm. There are many different types of focal points, and the dentist X-ray is different from a mammogram, which is different from a chest X-ray. And all of those modalities are different. And that makes it an impossible problem to solve at the current time.
Right. So in the sciences, what's the reality and what's still a pipe dream here?
It feels like it's a pipe dream to be able to get these things right. I don't think it will be. I think as we get more technology, I think as we get more the ability to regularize and get data in a way that looks as harmonized as possible, things will improve. But the problem is getting to that point. Harmonizing data is hard.
Yeah.
Let's talk about instruments, right? Let's talk about something easy that you go to the doctor with. Let's say you're pregnant. I don't know if you've ever been pregnant, Stan, but you're pregnant.
Not recently. Thank you.
But if you're pregnant, you go and you get an ultrasound, right? And there are very different ultrasound machines. There are handheld ones. There are big old cart ones. And anywhere in the world, there are data sets being created. Every day, there are women getting an ultrasound. But different women have different physicalities, and different machines have different exposure and, lighting and all of that stuff that goes with. So you've got all of these kinds of different data sets coming into it, and how do you harmonize and all. So I think right now we're in a period of like, how do we create data or extrapolate data or change data in a way so that when I do feed it into a model, those data are as harmonized as possible. They're, as even keel as possible, right? There is sort of the same, almost the same, near the same, but they're not all over the place. So I think that's where I see a lot of the work being done now. It's even in self-driving cars, it's creating scenarios that you wouldn't necessarily come across every day. Like, I can record all day long my driving, but there will be one day where there is a clown on a unicycle carrying an elephant, and that's not in the training set, and the car won't know what to do.
Right.
The best way to do that is to generate these, scenarios that are edge case scenarios, and generate enough of those edge case scenarios that a vehicle will know what to do come that time.
Right.
Amazon Web Services is the premier cloud platform for life sciences, empowering research, collaboration, and discovery. Learn more about what AWS can do for your research at aws.amazon.com/health.
So, from your experience working with many different companies, when companies go off and want to start using AI and machine learning, where do they struggle?
They struggle on the data part. The models are the easy part.
Yeah. So tell me, when you say on the data part, how does that struggle show up in their work?
Well, every time I went to talk to a customer when I was at NVIDIA, I'd say, what would you like to do? They say, well, we want to really take advantage of AI. We see the possibilities. We've seen the papers. And I'd say, okay, where's your data physically located? And they would kind of scratch their head and go like, what do you mean physically located? And I was like, where's the database? Where's the data center? And they say, well, it's, I don't know, probably about 17 different data in the databases. I don't know what you mean by that. So if it's not in a centrally located place, and has it been curated by somebody? No, we don't know. We actually don't know what's in there, but we have a ton of data. So a lot of the naivete of like what people thought AI was, which is like, here, take my data, go do something with it and put it in this blender, and out comes, a smoothie, AI smoothie. That's not how it works at all. Mm-hmm. You have to have the sous chefs, to continue on the food analogy, but you have to have the sous chefs to prepare. Otherwise, you're going to get, food smoothie every time out of the kitchen, and nobody's going to come to your restaurant. You have to get people that understand, know how to clean it. And even when you do that, the work that I was doing with cancer data out of the SEER program, where they collect these data each state, because cancer is a reportable disease. Even when we got the GOAT standard, that they called the gold standard, there were duplicates in there, and there was missing data in there. There was just like in columns where you're supposed to get text, you had nulls or characters or integers or something else that didn't belong in that. And so if you're going to feed that into an AI model, and the AI model is just going to, just balk at it. It doesn't know what to do. You're just going to get bad reading at the end. So that data prep to create AI is great if you have data that is clean, great, lots of examples, and is ready in a single place for you to feed it. The model creation part is almost not something that you really need to bother doing, because a lot of the companies have already created image models, language models, like for reading your email and guessing what you're going to type next on that Gmail account. All of those things you can just borrow. Those models are actually really useful for borrowing to apply to other scenarios in text or images. So you don't need to go create that. That's a research study. But that prep time, impossible unless you're able to generate new data. Now, if you can generate new data, great. Then you can plan and you can like set aside the instruments that you're going to use. And then at the end, you're going to say this model only works for instrument A and these, scenarios with these ages and between these time periods. And that's the best you can do. But to make use of everything else, so you have historic data, that is a huge, it feels insurmountable struggle right now.
Right. So what's preventing them from, overcoming that? Like, is just the volume, or do they have to start off thinking about, well, I might have to go back and curate some of that data?
Definitely. Yeah. So it depends on what the goal is, right? So if you're at a company where you have tons of data and that is your bread and butter and you want to make use of all of this historic data, like I worked for, the agricultural genomics company, we had nearly 50 years worth of genotype, well, not genotype, but phenotypic data. We had 50 years worth, and genotypic data we had about 25 years worth when we got there. And to make use of that was fantastic. And in fact, when I created a database to put that and mash that together, I ended up creating, which is actually what I'm working on now, as a columnar store of genomic data. And once I put it in the same database, so I had historic data of, let's start with an example. So we had animals that were tested for certain genes that were made them susceptible to certain diseases or certain issues. At the first few animals in the beginning of the historic data, we had only maybe like 16 gene panels. It wasn't a lot, maybe a singular gene, maybe it was single gene panels, single mutations. As the historic data moved, forward and more modern, we had panels that were 200, genes or SNPs in this case. So 200 SNPs, 256, and then, 1,000 SNPs. And then at the end, when I was there for the cattle, we were doing something like 850 something thousand SNPs for cattle. That's a huge gap in data, right? So if you imagine a columnar store with 800 something thousand, imagine a database with 800, columns, right? So you have animal IDs on the left side, there are the rows, and then 800,000 columns for the SNPs. You wouldn't be able to put that in a regular database. So the best case scenario you do is say maybe a CSV file, and you break up the columns, right? And you break up into multiple CSV files. That's insane. So what we did is, and what I did at the time is I got this budding new startup. They were building a columnar store, and we were able to store 800,000 columns because it doesn't matter, because it breaks up the columns automatically, and then we could search through the data set in parallel because everything was broken down.
Right.
And what ended up happening is we realized that we could impute, because the company was breeding the animals, they knew, who the mom and the dad were, and they could say, well, chances are these progeny, the baby piglets or the baby cattle will have these genes, right? And they could infer with a certain probability, a certain certainty, what the genes might be.
Right.
And so we realized that we had densely genotyped animals and sparsely genotyped animals. And we could infer the genetics of the sparsely genotyped animals in what's called in that field imputation. So we could impute the genetics of the family members and et cetera with a certain certainty based on the densely genotyped animals. And so that the cost of genotyping, instead of genotyping every cattle out there for 850,000 SNPs, we didn't have to. We realized that this was a statistics problem. We only had to genotype certain, animals very densely, and then the other ones we can sparsely genotype, and then from there we can calculate what the rest of the genotypes were, and that completely changed the business model for that company. Instead of saying, "Oh, if we want to do genomic data or anything on AI, we have to get everything, correct, and then we have to get everything dense." So, in the same flavor of what we were doing then is what's happening now in AI. Maybe I have some really high fidelity information for certain things, and I can impute from poor fidelity data what that might look like, and I can generate new data based on what that looks like, and then from there move on to actually doing and training an AI model.
Right. So going back to that history problem, it really is up to the company to decide, is this historical data going to be a part of the value of our business? And if that's true, then you have to really go back and curate that historical data because it's part of the business model. It might even be part of the product that you're
Correct.
selling as a result of that. So going back case by case, but it sounds like in large organizations you could be trying to boil an ocean, and that might not be the most effective use of your time.
Exactly. And maybe, one of the things that I gave a talk about at that BioIT conference was that you need to hire statisticians. Statisticians are going to tell you how much you need to be able to train a model. Because remember, in the end, AI is 80% linear regression. And then there's
Right.
that 20% that's like neural networks and, more complicated models. But what you're doing is what statisticians and mathematicians have been doing for a long time. You're just using a computer to traverse more states and traverse more scenarios. But what you need is a statistician that can say, you know what, in this case, we probably just need 10% of this data. Or in this case, we could do a really good job if we were to use 1% of the data. I can imagine that like an insurance company that has had all of this historic data could come up with ways where they don't have to curate everything. They just have to select a few high fidelity individuals and then use that to infer what other individuals might
Right.
be, and then infer that data, use that as a training model for a new model, and then do some AI on that.
So that's a perfect segue, Fernanda. Back in 2021, in your presentation at BioIT World Trends from the Trenches talk, you had
Mm-hmm.
a slide that you walked through, which was, what are companies doing right and what are companies doing wrong? I would love it if you could kind of revisit that list for us and, take a look at it from today's glasses and binoculars or whatever, and kind of run through that with us again, because I think it was very well received.
Yeah, so the context of BioIT is that we're talking to a lot of folks that are dealing with human data, biological data that has some sort of human connection. So the first thing that I had there was data curators and ethicists. So we already talked about data curators. These are people that know the data. These are people that have an understanding of the sorts of things that should be there and shouldn't be there, what to expect, what not to expect, because those are the things that are going to break any model that you put through, any machine learning model or neural network. And then the second step is hiring an ethicist. I think we should hire ethicists for all of AI, to be honest, because if at the end, the customer is a human being, the ethics, for example, of something as simple as, going back to the pregnancy example, somebody went to a store and bought some stuff, and then it might infer that you're going to have a baby. So I saw actually something on Twitter where they sent a package to someone inferring that they were going to have a baby. And so they had like formula in a box and diapers and something like that. So they got data from, say, a pharmacy store where you had purchased something, inferred that you were having a baby. And then this company that had that data, had bought that data, sent you a package, a care package, which on the outset looks good. But, what if you were if you were not planning on a baby, or maybe it's not your spouse's baby, and all of the issues that go along with,
Right.
recent Supreme Court stuff that happened in the US. So hire an ethicist, because if the data is going to be consumed by a human or going to be used to make decisions that humans are affected by, an ethicist needs to be there to be able to say, here are the risks for us, because these are risks for your company. This is not just about, hire an ethicist to do the right thing. But, if that's not enough of a motivation for you, which should be, but it's also a risk for your company, risk for lawsuits, or even, major lawsuits or issues with regulatory issues. So you want to hire an ethicist to be able to find somebody that's constantly thinking about what are the risks that we have here in doing and manipulating this data.
Anything else on that list?
The things that I think
are changing a little bit. Actually, I was surprised the other day. It has changed so fast in the last 2 years, Stan. It used to be that I think about the max, when I gave this talk, the max amount of data that was actually on the cloud was about 40%, and we've gone over the 50% mark. We're actually into the 60 to 70% mark where companies are using cloud to put their data in the cloud. And that's surprising to me, because maybe it's just showing my age, but there is no way that, if 2009 Fernanda would have put historic data on a cloud service and felt safe because that was our bread and butter, is the historic data that we had.
Right.
But people are feeling so much more comfortable with cloud today, and cloud companies have done so much more about security and co-location of data stores and et cetera, where people are feeling much more comfortable putting their data in the cloud. And it's also, a highly connected world. So I can feed data directly to like an S3 bucket, et cetera. And that shift from cloud, a lot of cloud, but still having some on-prem makes it difficult to do a lot of the work that needs to be done for you to do AI. So like tagging work or curating the data, or having data physically in the same place so you can do that compute, right? So if your data is closer to the cloud and that's where your compute lives, great. But if your compute lives on-prem, then now you've got to have that data egress, and you've got to pay for the egress, et cetera. So I think a lot of folks are now thinking about, where do I put my AI? Where do I put my data?
Right.
Where do I put my compute? And then the last part of it was basically saying, focus on narrow problems and don't go reinvent the wheel. Reuse models that already exist, reuse the models that are already mature and built, and try to fit your problem. It's easier for you to fit your problem into a natural language processing problem, or fit your problem into an image, detection problem that a model already exists from Facebook and Google, than it is for you to go create some sort of narrow, one-time specific model for whatever it is that you're trying to do. So reusing models, if your scientists or your data scientists are saying, "Oh, I'm going to create a model and then work from there," then forget it. That's a PhD project. Say to your scientists, "No, we're gonna turn around. We're gonna look at something to reuse and try to fit a problem into there, and let's get our research out of that, and let's just do the research on the actual data itself." So those are the things that companies that were doing the right thing,
what about wrong?
Were doing.
Yeah. What about those? What about what you see people doing wrong?
Well, what I saw and I still see is a lot of AI startups getting bought. And I expect now, with a little bit of the downturn on the economy, that people are going to be looking for an AI startup bargain. The problem with buying an AI startup, and I'm not talking about people building the infrastructure, I'm talking about people who are saying things like, I can tell, I have created a new model that can tell you whether or not this CT scan's got, cancer or not, is that they're all working off of basically public data. They're all basically working on the same kinds of data that everybody else has available publicly. So chances are you're not going to get a lot of value or be able to tell what the value is from company A and company B. That doesn't mean that the AI startups are not doing the right thing. What it means is that you're much better doing an intermediate step of partnering with them and maybe hiring them to work on your data, and so they can look at real data and see if their model actually, survives, than it is for you to absorb their IP. Because at the end, the differential between AI startup IP and one to another is going to be very, very little, just based on what they're doing. So that was like number one on my list. Stop buying AI startups, work with them, actually provide them data. And the second one is, we talked about ethics and ignoring ethics, but the second one is just starting out from historic data is one thing that you can do, but you should maybe just start fresh. If you're new to AI, just start fresh. Find some specific problem you want to solve, an instrument that gives you very regular data. Maybe if you're, again, in the health industry, you want to do MRI stuff, go do MRI stuff. Like pick some specific MRI machines and then go do that on that specific MRI machine. But also remember that you're probably not going to have enough data. And I think what's going to change the world is when we start learning how to share data with one another, that the differentiator is going to be how you do the service and not necessarily the data that you hold. And that, I think people that understand that and see that will actually benefit far more than people who are thinking that their data is gold and they have a lot more than the next person, and therefore, we're going to do a better value we're going to have a better value proposition, or be able to get better value out of it. Chances are, unless we get this stopgap of creating new data or generating synthetic data that can help, chances are you're not going to really get something valuable, at least that's customer facing, in the long run. And then the follow-up to that was to say, if you're going to use AI, just use it internally. Don't use it for something customer facing, because your chances are you don't have enough data. I would be very surprised if you had enough data, and you should probably just do something to maybe improve some complexity in your processes. So if you've got let's say you've hired 100 people and 100 people are doing some sort of very manual thing that they're making sure, or processes that are manual, maybe you can fill out forms that are, much faster. And now these 100 people can be doing something that's much more valuable for the time that they have in your company. Do that. So use AI towards processes as opposed to towards diagnosis. Let the diagnostics and that world remain a little bit longer in doctors' views, or use it as an accessory. For example, hey, pathologists, you should probably take a second look at this slide because we think there might be something there that you missed. That's a much better AI proposition than we can replace pathologists and do a better job than they can. That's not going to fly well with pathologists, and you're probably going to be wrong.
Right. So in our final few minutes, I'd like to just ask you a little bit about your current situation and delve into whatever you can share with us on that new opportunity that you're working on.
Yeah, so Voltron Data is made up by some folks that used to work at NVIDIA and also some other startups where they were working together. And their goal is to solve this problem of bringing data together and making accessible data easy to use, or making data easy and accessible. And what we're working on is based off of some open source ecosystem that's based on something called Apache Arrow, which is a language agnostic columnar in-memory format. And that's a lot of words, but basically, instead of a row-based database, this is a column-based database, like I mentioned before, that I did for my first job. And what that does is, if you imagine, I'll explain the difference really quickly here. If you have a spreadsheet, like an Excel spreadsheet, and you wanted to locate something on that spreadsheet, your human eyes would not go down to find the individual. If you were looking for, say, something in a column and say, give me all the things in this column that are less than 0, right? You would not go down each row and identify the individual and then move all the way to the column. And that's what a relational database, row-based database usually does. What it does is there's a little cursor. And if you imagine, you just start at the top and you go down the first row and you wanted to read that column, you would start at that row and you would move your cursor all the way to that column. And you'd be like, is this greater than or less than 0? No. Okay. Now go back and then start at the next row, go all the way to that column. Is this? Yes, it is. It's greater than 0. Okay. Go back. Next row. Is this less than 0, greater than 0? That's how row works, which means that you're traversing every piece of memory in your hardware. And that's extremely slow. So if you've ever felt like the database that you're working with is so slow at getting something that you're looking for in a specific column, it's because there's probably a lot of things that it's trying to traverse and literally walk and move this cursor to read memory spaces until it gets to that space that it needs to make a decision on, and then go back and go to the next row. Now, a column-based system is different. It starts off with just a column. I want to read and tell me everyone that's above age, 40. And you go to the age column and you go like age 40, yes or no. up or down, and then you just grab the ID. And is it 39 below age 40? Okay, no. Is 45? Yes, above age 40, grab the ID. And so all it does is it does work on that specific column. And now let's say you want to say, I want to get everybody that's above age 40, but also I know lives in the state of Michigan. Another CPU core is working on the state of Michigan column. Your first core is working on the age column. Now you want to do I want everybody that's above age 40 in the state of Michigan that is left-handed. Now it's working, a third core is working on that. And that's so easy for you to scale searches. And that means you can do live searching through your data. And now if you put that in memory, and if you have this backend that knows how to bring in memory as it's doing the search, that means that this backend is loading into your regular RAM, and it does it automatically. So you're searching through this data super, super fast. And you can do these live searches super, super fast beyond the actual amount of RAM that you might have on your laptop.
That's fantastic, Fernanda. I guess we're running out of time right now, and I definitely need to have you back again so that we can continue talking about more of this that you can share with us in the future. But really,
I would love to do that.
Yeah, it's been wonderful talking to you again, Fernanda, and I look forward to having you back again and updating us on this really very important technology that you're working on, because we're kind of far from fair if you think about it. So we have to solve that problem to make data accessible to everybody, no matter where it lives, and find it and use it. Okay, thanks again. Take care.
Thanks, Stan. Bye.
Bye-bye.
Thank you for listening to BioIT World's Trends from the Trenches podcast.